Hello everyone, welcome back to this channel and welcome back to this mini YouTube video series that aims to look at different data formats and tools that you can use to handle, parse, and perform data analysis within them. In this video, we will be looking at an HDF5 or the hierarchical data format type. And we will look at different tools within Python to analyze, create, and read those types of data formats. So without further ado, let's get started. The hierarchical data format HDF version 5 was designed to store and organize large amounts of data. It is a great mechanism for storing large numerical arrays of a homogeneous data type, and for data models that can be organized hierarchically and benefit from tagging that data with metadata that describe it. It can be read or written into within different platforms like MATLAB, and there are different bindings available for different programming languages like Python, C++, and LabVIEW, among others. This type of data format is widely used in the scientific field to store large amounts of data. To better understand the capabilities of the HDF5 data format, let's visualize an example mentioned and demonstrated in the book Python and HDF5 by Andrew Colab. Let's say we have a temperature sensor that is giving us temperature readings at a certain time interval from a certain weather station, and we would like to store that data. We can easily do that with the help of libraries such as Pandas and NumPy. Now, what if we wanted to also store some metadata related to the temperature readings that we are receiving, such as the interval at which the temperature readings are being received, or the location of the weather station? That would also be simple with the help of NumPy or Pandas. Now, what if we had more sensors within the weather station that we would like to record the information of, such as a humidity sensor or a wind speed sensor, and its metadata? And what if it's not just for one weather station, but many weather stations? As you can see, this becomes a little bit more complicated, and using the HDF5 data format can easily organize this data into a hierarchical system where we can group data that are coming from a specific weather station into certain groups, which are similar to folders within a folder system, and assign them attributes that represent the metadata, such as the time interval at which the measurements are being recorded and the start time at which these measurements has started to be recorded. Now, how can we organize this using the HDF5 data format? The HDF5 is similar to a folder system. So if we wanted to organize this in a hierarchical system, we can create a dataset as the main file, as the root file, and within it assign subfolders or groups that represent each different weather station, and within each group we can assign it some attributes, which is in our case the measurement interval and start time, and the arrays will represent the data coming from each sensor. In this case, it's the temperature, humidity, and wind speed. So now that we've gained some understanding of how the HDF5 data format behaves, let's jump over to the code and examine its capabilities further. Okay, let's create an HDF5 dataset. To do that, we need to use the h5py library, and therefore we have imported it here. And to create let me delete this so that we can start fresh. And to create the HDF5 dataset, we can use the .file, pass it the name of the file that we want to create, and the mode of operation for the file management in Python. In our case, we want to write into a new file or overwrite into an existing file, and therefore we will use the W. If we use the R, it will open up the file that we've mentioned here as read-only, but it should exist. So in our case, it's not there, so we could not open it. So let's just undo that. The R+ will open read-write, but the file must exist, and A will open read-write, and it will create the file if it did not exist. In our case, we just want to write into a new file, and we've created the dataset.hdf over here. And we've assigned it the F. So if I look at the .name of the F, we can see that this is like a file system. So we're in the root right now. And we aim to create the same structure that we saw in the video, where we have a dataset group, and within this group we have two groups for each station, and this could be for numerous stations. And within these groups we have arrays of data that we want to store within this group, which is the station number 1. And we also want to assign each group some attributes which represent the interval of measurement in minutes and the time of start measurement. And that's basically what we want to do. So to do that, we need to create a group known as dataset. So this one. Then within it, we want to create subgroups. So we use this dataset and we create group within it. So we have group station 1, group station 2. So if I run this and I look at the name, which will show me the path, I have dataset station 2. And if I wanted to do the same for station 1, it will be dataset station 1. And within each station 1 or 2, I want to assign the wind, humidity, and temperature as follows. And we don't need to fill it in with data. We can create an empty data set that we can fill with data later on, and we can assign the size. So it can be a matrix of 10 by 10 by 10, or I can just assign it a size of 10. So it's a one-dimensional array of 10 values. Similarly here, just to keep things simple, let's assign it a one-dimensional array of size 10. And we have created 3 data sets for station number 1. Similarly, we've done the same for the second group, wind, humidity, temperature, but in this case, I will also change the size of the dataset, the empty dataset that we will create for the second station, to be a one-dimensional array of 10 values. And the type will be integer as well. Okay, so let's just run this. So if I look at the path of the dataset 1, station 2, which should be the wind, I can see that we have the first group, which is the dataset, the second group, which is station 1. So this is the big group over here. And then this is the subgroup, which will contain the information, wind, humidity, and temperature. And these are one-dimensional arrays of size 10 of data type integer. This is what we've specified when we created the data set. And we have done the same for station 2. So looking at dataset 1, station 2, we have this path. And if I look at the same for station 1, we have the same. Now, what if I also wanted to assign attributes for each of these groups? So this station has an interval of measurement of 30 minutes and a time of start measurement, which is this thing over here. We can do that through using the .attribute, where we can create an attribute of start time, just like that, and assign it a value. Similarly, the same attribute for the group for station 1 of interval in minutes, and assign it 30. So this is essentially how we can create attributes for each group. We can just use the .attrs and just create the attribute, assign it a name, and set it to a certain value. If I wanted to assign each of these data sets values, we can do that through, so assigning value for station 1, we can do that through assigning this a list or array of evenly spaced values using the NumPy arrange. If I go ahead and look at dataset station 1, I can see that these are the values for dataset 2, which represents the humidity. And similarly, we can see that this is the values for the temperature, for station 1, etc. Now that we've created the dataset, assigned each array some values for station 1, we can do the same for station 2. We can also look at the temperature readings for station 2, and we have some values within it. Now that we've created this, filled it with information, we can go ahead and flush this into the file and write to the disk and close the file. Now, if I look at the contents of the contents folder here, you can see that we have the dataset HDF5, and it contains information. So we can see that it has a size of 6.1 kilobytes. Now let's look at a HDF5 dataset, more specifically OpenPMD, which is a dataset that contains information about different particles with information about their charge, position, momentum. And let's look at the structure of the HDF5 file and read into it. To do that, I'm going to clone this dataset. So if I refresh, I should have the OpenPMD examples dataset file over here. And we have example folders. We have this as an H5 folder or HF file, this as well. And we will use this one to just look into it. So similarly, we will use the h5py.file, specify the path of the file that we want to read, and we've specified the operation as read. And then we can look at the different hierarchies within this file using the .visit, where we can print all the paths. So we have the root of data. So this is the first group. Within this group, we have a group of 1. Within the 1 group, we have meshes group. And within this, we have subgroups of B, subgroups of E, and within each subgroup, we have the arrays of X, Y, and Z. So let's say we want to look into one of these arrays, which is the X. We pass it the path, and we can save that as a data set. So this X has a shape of 47 by 47 by 47. So it's like a 3-dimensional shape, data shape. And we can assign all of these values into a variable as follows. And when I print it, so if I do this, so I just obtain the data set, and then when I assign it into the X array, I get the 47 by 47 by 47. Now, if I wanted to observe the attributes of this specific group, or this specific data set, I can use the .attrs and look into the key value pairs, and we can see that there is a position and there's a unit SI value. I can do the same for the Y, or I can do the same as well for the B. So let's look at the attributes of the B. So let's say we want to look into B. So B equals files. So I'm going to take in this path and b.address. We have, okay, let's assign this to within work keys and values within the B items. Just print the keys and value. Then let's observe different attributes that this group has. We can look into an HDF5 folder and examine it, get data from it, understand its structure, look at its attributes at different levels. And so I hope you've learned about the HDF5 data format and learned how to create one, how to read one, how to assign groups, datasets, and attributes while creating an HDF5 dataset, how to read an HDF5 dataset, how to get the data or arrays of data within one group and the attributes of a group. And yes, I hope you found this video useful. Stay tuned for the next one.